we've been trying to prove or show how triangles are congruent. Today, all I'm worried about is being able to figure out if they can actually be a triangle or not. And so that's what the triangle inequality theorem tells me, or shows me what I can do, is I can figure out if the three sides that I'm given can make a triangle. So what that says is a triangle exists if the sum, that means add, right? If the sum of the two shorter sides is greater than the longest side. So what that is telling me I have to do, I'm going to make this note in this little white box over here, is I have to add together the two shortest, and then compare to the longest. I'll give you a couple of seconds to make sure you get that down. And if you think about it, it makes sense. If I have, let's say this pencil is my longest side. If I have two sides that don't add up to be longer than this, there's no way I'm going to be able to connect back and actually make a triangle, right? Because they would have to add together and be longer, because it would have to go down or up and then back up, or up and then back down, right? And so all you have to do is well, it says prove your answer if an inequality. But I find my two smallest, if it gives me the three sides. That's 8 and 17, right? Well, 8 plus 17 has to be greater than 24. That's my first step. Then I actually add them. 8 plus 17 is 25. And then I look, is this true? Is 25 greater than 24? So that is yes. Then when I go to number 2, my two smallest are 3 and 3. Okay, so that's 3 plus 3 is greater than 7. I still write it as 6 is greater than 7. But is 6 greater than 7? I put a little line through that because that would mean not greater than. And that would be no. So 3, 3, and 7 could not be the three sides of a triangle. So now you need to take the next few minutes and do 3 through 8 on your own. Then we'll come back and do the bottom side.